All right, well, hopefully you've had a chance to try this video. I'm going to walk through the solution, and I'm hoping almost that you ran into a few areas that were a bit confusing around M sub L. So we'll talk about that in detail and kind of develop a strategy for managing that in the future. So in this practice problem, we want to draw orbital shapes for the following orbitals. And so what these numbers are doing is describing an orbital. Now, each of these orbitals can contain 2 electrons, and that's where that spin quantum number comes in, the spin up or spin down. And so we're just focusing on the shape of it rather than which electron it is in it. And so we're going to separate each of these out. So for our first one, we have an n equals 2 energy level. Great. That means we're going to have one node. So n equals 2 tells me that I have one node. L equals 1 tells me I have a p orbital. So a p orbital will have one planar node, so that means I'm not going to have to deal with radial nodes in this particular one. And then an epsilon L equals -1. So that's going to give me the orientation, the xy axis. So I know already that I've got this p orbital like this, and then I have here we go, let's draw it. Let's draw it here. There we go. And we'll do this as z, x, and y. That's how I tend to do mine. And so for this one, that m sub L is going to be just one orientation, either x, y, or z. And honestly, the indication of -1, 0, or +1, it isn't as critical for me, as long as you are recognizing that we have a p orbital that has a node at the center that would have 2 different phases like this. And so I've drawn mine as the py orbital here. All right, let's look at our next one. I'll change colors. So this one we have n equals 1. That tells me we have 0 nodes, right? Because our nodes are always n minus 1. We have an L equal to 0. That tells me we have an s orbital. And we have an m sub L of 0, which makes sense because you can only have plus or minus L, so it's only going to be 0. So thinking about this one, sorry, I'm going to draw my XYZ axis again. And I don't have any nodes. I don't have radial nodes to worry about because I'm in that n equals 1. So I'm just drawing a sphere. And that's it. And that would categorize that would describe that set of quantum numbers. It's representing an orbital that has this shape of just a sphere without any nodes. All right, let's switch now to our third one. Okay, so this one, we have n equals 4. So that tells me that we have 3 nodes total. Because it's always n minus 1. Now I have an L equal to 2. That tells me I have a d orbital. So d orbitals have 2 planar nodes. Therefore, I'm going to have, since I have 3 nodes total, I'll have 1 radial node. Whatever remainder I have after I use the appropriate number of planar nodes to create the shape that corresponds to L, those will all just represent radial nodes. So I'll have 1 radial node and then a d orbital shape. Okay, last up is m sub L. So m sub L can equal -2, -1, 0, +1, or +2. And we have an m sub L of 2. So we're really looking at this one right here. But which one is that? There's 5 different orbitals. And so this, I don't think this is in your textbook. I dug this up from my notes from forever ago. It's something I forgot. In general, if you can take this information and draw any of your d orbitals, I'm going to be happy that show a radial node. But let's take this opportunity to go a little bit deeper with it. So I'm going to do a little bit of erasing, or actually, let's see if I can do it. So I'll do one big one, and then we're going to have some smaller ones down here. So I'm going to say that the +2 is going to correspond to the dx squared minus y squared orbital. And I'm going to post a picture of a categorization based on the m sub L for which orbitals correspond to which on this page that you'll see this video on in Canvas. So if you're watching this on YouTube, check Canvas. But what we're going to do is we're going to say our plus 2 is our dx squared minus y squared, and that our negative 2 would be kind of its counter 1, which would be the dxy. Then for our plus and minus 1, we're going to call that our dy squared, or sorry, our dxz, and our dyz. And then our zeros are dz squared. So I'm going to write these out here, and we're going to look at, so this would be our plus 2 here. So this is going to be our minus 2, minus 1, 0, plus 1. And then this is going to be correspond to dxy, dxz, dz squared, and dyz. And this is our plus 2 right here up at the top. So I'm going to build the one that it is, and then I'll show you what the other ones would be in case you drew them all. Now this is going to line up right along the XY axis, which makes it really different from our XY, which goes in between. I'm going to shade in these two right here to show that I understand that there is a difference in phase between these lobes alternating. And then, so that takes care of my two planar nodes, and it shows the dx squared minus y squared shape and orientation. But to deal with the radial node now, I need to show that there is like a spherical layer where there's no electron density. And the easiest way to do this in a drawing is to draw another kind of like layer to the each lobe and to shade it the opposite color. So I'm going to come in through here and just create these extra kind of spaces for the lobe there that are opposite color. And then I'll do this for all 4 of the lobes. So this shows there's this kind of layer of no electron density that happens in a spherical way that is around the entire lobe embedded within it. So now in case you drew the other ones, I'd like to walk through what those would look like too. So if you're doing the XY, you're going to instead have the lobes in between the X and the Y axis. And so this would look something like this. And again, you're going to have that radial node that comes out as a different color, kind of like that gobstopper layer, except we're looking at it from the perspective of orbitals. So that would be my x, y. If I was doing x, z, then I'm going to go in between the x and z axis. So that c is at the top and x is right here. So it's coming up and out at me. And I'm going to shade in 2 of these lobes opposite of one another to show my phase transitions. And I'm going to come in and add in this extra radial node by showing a change in color here. Like that. Now for the dz squared, this is my favorite. It's the one that looks different from the other ones. This one is really characterized by like this donut shape in the middle, followed by this P-style lobes on either side. I'm going to color in the middle. It's like a donut of sphere. So my drawing isn't great. And then you would have another sphere for that radial node. Oops, sorry. That would go around it like this. And then we'd have that same thing for the lobes on the top and the bottom. And we would show an alternating color to show that we know that there's no electron density between those 2 phase changes. All right, last one, dyz. So that's going to be between the z and the y-axis, and it's going to go right in between them like this. And we'll color it in, and we'll put in our radial node. That. So those are the kind of 5 possibilities for the d orbital with a radial node.